When it comes to programming, the more that you know how to do, the more that you'll be able to do. It's like playing a game. You want to know every different move, every different paradigm you can put to your advantage. My name is Terrance with Java Code Geeks, and today I'm going to teach you how to write cleaner, more efficient code by using functional programming. Alright guys, now before we get started, if you look down in the description, you'll see the related content and articles from the Java Code Geeks website, where you can stay up to date with everything Java related. Now, if you guys are enjoying this content, please smash that like button, hit that subscribe button, so that way you can stay up to date with all of our latest videos. With that being said, let's get started. Alright guys, so here we are. We're ready to take a look at some functional programming examples. Now first let's look at this term of function. What exactly is a function? It is a reusable piece of code that can be placed throughout your application for the purpose of accomplishing something for your program, right? So we can reuse this. This can be used interchangeably with the word method. Now a method is more closely associated with object-oriented programming, but they're essentially the same thing. But first, we're going to look at this higher order function, and we're going to look at a first class function. So what is a higher order function? It is simply a function that's able to have a function pass as an argument to it, and it's also able to return a function. So we can see that here that this is a higher order function because it's actually returning this function here, this method a dot compare to b. Now, in the same way, this is a first class function, right? Because a first class function can be, you're going to hear this term a lot, it's going to be treated as a first class citizen. And all that means is just like any other data type, it can be passed to a function and it can also be returned from a function like any other data type. So when we see that here, we can see that this function is a first class function because it's being returned. And this is a higher order function because it's returning another function. So it's very powerful stuff that you can use for your program to fulfill the needs thereof. And we can see that this does work correctly because it's going to call this other function compare, and it's going to arrange these in the correct alphabetical order. Now we're going to look at a pure function. A pure function is essentially a function that has no side effects. What you see is what you get. When this function runs, it's going to perform this calculation, and it's only dependent upon these two arguments that are passed in here. Nothing more, nothing less. Whatever is passed into as an argument will influence the outcome of this function, and it's only dependent upon those arguments. So we can see that here, no matter what happens, this function is always going to evaluate to 3 because we have 1 and 2 here. It's going to add those two numbers together and we'll never get another answer there. So when we run this code, we can see that we get the answer 3, and that's because this function is pure. There's no other side effects. Now, when we look at a referentially transparent function, right, we're going to take a look at referential transparency. This function is also dependent upon its arguments completely, but there are some side effects. So as we can see here, this function, this type of function actually has state being held here. This variable is being increased, right, by a post increment operator. It's being evaluated and then it's being incremented. And we can see that down here, it's not going to give us the same answer even though we're passing in the same arguments. So yes, this function's outcome is dependent upon its arguments. However, this function needs, or it's actually going to have this side effect occur, and it's not going to give us the same answer each time, unlike a pure function would. So when we run this code, we can see first we get the number 4, and then we get the number 5. So we're never going to get the same answer. It's going to continue to increment. Like we said, it's like a pure function in that it depends upon its arguments. However, it does not, or it doesn't have side effects with it. So now when we look at a lazy evaluation, this is basically a way to short circuit your code here. And these are short circuit operators, the double pipes here. So when we see this information here, we can see that this function is going to run, and it's going to come down here and it's going to say this value is true. So it's not even going to evaluate this other side of the double pipes. It's going to short circuit the operation, and it's going to be lazy. So this is lazy evaluation. Yes, this information over here, it's there, but it's going to be lazy because it already has a true value on this side. It does not care about the other side. In that it's going to be lazy. It has the true value in y. That's good enough for the function. So when we run this code, it's going to evaluate the true, even though this side of the function evaluates to false. Because it's lazy, it's just going to go through there. Now, when we see this information for recursion, what we're looking at here is this is when a function is able to call itself in a circular manner, or it can call another function that's able to call itself. And we can see that here in this example. So when we see that this Vibo function is actually being started here, and it's going to call itself with various arguments here. Now, when we look at this function, we can see down here where we pass in the number 17. And this is basically going to give us a line of numbers that are in line with the Fibonacci sequence. You can look at the Fibonacci sequence online, research it, what it is and what it does, or why it was made up. And so, but the most important thing is to know that yes, you can write a function that actually returns itself. So when we run this code, we can see that here. We can see these numbers that are output, and this is all generated from the function calling itself. All right, guys, and that's going to end our functional programming example. Well, guys, I hope you enjoyed that video. If you did, please smash that like button and hit that subscribe button. We have more great content coming up soon.